want to do another data miner kata! Let's go! Yeah! Hello and welcome to another Bringing the Thunder. That's right, we have another exciting kata exercise ready for you. Now, you might notice I don't really have a guest around me, and also I have a little bit of a different background. That's because our guest today is remote. So let's bring him in and let's listen to what he has to say. Hello, can you hear me? Hello.
Hello, yes, I can hear you. Can you hear me?
Yeah, I can hear you perfectly well. Thank you very much for joining us. So before we jump into anything, I want to know, and the viewers want to know, who are you? What do you do here at Skyline? And because this is remote, where are you from?
Yeah, sure. So my name is Adib. I've been system developer at Skyline for a year and a half, and I'm from Bosnia and Herzegovina,
From Bosnia
specifically
and
Sarajevo. Yeah, it's a
Nice.
capital.
Nice. So you are remotely calling in, phoning in to show us something very nice, something fun that you've been working on or playing around with. What is it? What is the topic of today? What have you got for us?
Yes, this is something I've been working on, and the topic of today is the performance analyzer solution. So basically, it's a two-part solution for collecting the metrics, which is a generic library that can be used anywhere in any code, well, C# code. And the second part is the low-code app that is used to visualize the collected metrics and to make them easy to understand and make decisions based on them.
Perfect. So like a two-part thing that we have here, and then they combine into something very beautiful.
Yes.
Okay. Good. Any prerequisites? Should we install something? Should we have a DAS setup, or can we do that anywhere? Or?
Yes, we do have a couple of prerequisites. The main one is, well, all of them will be satisfied with DAS. So spinning up a DAS will solve all the data miner related prerequisites. Another prerequisites for this specific kata will be Visual Studio, GitHub, and the DIS extensions. And regarding those who are maybe using on-premise agents or something like that, the prerequisite is going to be data miner 10.5.2, specifically one with GQI modules enabled. Or if the modules are not enabled, it can be data miner 10.4.0. And in that case, the nugget will have to manually upload it to the files project, so it's the GQI compiles.
10.5.2, and you have everything pretty much if you have the DXMs enabled as well?
Yes, if you have anything. Yes.
Perfect. Okay. And do we need to install some kind of package to get started, or?
For this specific exercise, the package will be included, but for the library itself and using it in your own custom solutions, there is a library available on the NuGet store that you can download and then have access to all the necessary things to start collecting the data.
All right.
And if you want to visualize the data, there is a item on catalog that can be deployed. Actually, it's not this one. That can be deployed, and then you will have everything you need to visualize the collected data.
That'll be the low-code app then you were mentioning.
Yes, this will be the low-code app.
Cool. Okay, well, what do we do? How do we get started? What have you got?
Okay. So first off, to start, we have created a repository that you can download and clone. And that will be our starting point for everything else. Now the repository is a dummy database interaction that mocks some things like connecting to database, fetching data, and stuff like that.
Okay.
And it can be downloaded from our repo. Once you have downloaded the repo, you can open the solution, and then you'll notice a couple of folders and files. The most important one for our case is the database controller class,
Mm-hmm.
and everything in else is there to support the visualization of this class.
Okay.
Now, do you have a question or?
No. Keep going. It's great. So we clone that specific repository, and it's a tutorial or it's an example. So it mocks out a lot of things or it fakes a lot of the access, but we can
Yes.
use it now just as a kind of to play around with it, to work with it. So
Yes.
we either download it or we make a fork of it or whatever you do. But if you have it on your local machine, you can play around with it. If I got that right.
Yes, exactly. Also, for those who maybe don't have or don't want to use Visual Studio, there is a catalog item as well. Let me just find it. That will do the same things that we publish manually. And since we're gonna publish a couple of versions, there's a couple of versions that people can deploy, and all of these are just different iterations of the GQI that we are going to implement.
All right. So those are pretty much like kind of the cheat. If you
Yes.
don't want to program, you could theoretically
Yes.
just deploy each exercise. And hey, I mean, sure, why not? Seems like a good way. If you get stuck somewhere, you could see what it's supposed to do and act like. So very good. Okay.
Yes. I wanted to, because the library part of the solution is technically specific and developer can only use it or implement it. But the low-code app is something that anyone can have a look at. So even end user who's maybe not in the technical aspects,
Could already make something with the UI there in the low-code app. Yeah.
Yes, so they can have a look and see, okay, I'm not happy with the performance of system. It's been faster before, it's degrading, why, and stuff like that. So that's why I provided the catalog items as well. So quickly now, we'll just add a new query. Well, first we'll have to publish it. So we'll publish the query. I'm using my local host, but that's regardless of what's being used.
So so currently we begin by pretty much making no changes to the code we just closed.
Yes. We just want to create a table that we're gonna use to visualize performance issues. Now that we have this, we'll refresh the page. We'll open the queries and we'll add a new ad hoc data source, which is gonna be employees table. And the employees table is the mocking thing in this exercise. We're going to create a table and publish it, and that's it for a start. And now we can already see that this is taking a while.
Yeah.
And it's going to spin about 12 seconds.
Okay, so this was the table, and you're grabbing the data from the GQI query we just uploaded.
Yes.
Okay.
All of this is mocked, the database is mocked, the executions are mocked, but the general idea is pretty simple. We connect to the database, we fetch the data, we process each employee, we store the data, and we disconnect. Now we notice that the loading takes a while, and the question is why? And there's a couple of things that can go wrong, and maybe at this point a question for you.
Sure.
What's the first thing that pops into your head, how you might figure out where the bottleneck is?
Oh, well, yeah, depends. I mean, if you're old school, it's going to be adding some log lines in between things and checking how long it takes between each line of logging to happen. Or you could, if it's specific database technology, you could connect to that database and try and get some tracing from there. Those are kind of the steps I'd start with.
Well, yes, that's a natural approach, and all of those are suboptimal because, for example, going through logs, it's not obvious which ones have a large separations between them. And this is where the performance analyzer comes into play.
Okay.
So using the performance analyzer, we can collect metrics of each of every method or every snippet of code that might be of interest to us, and then we can easily visualize it, making it obvious where the issues lie.
Okay.
Now we are going to implement the performance analyzer quickly. Now a couple of things need to happen. We need to define performance collector. Actually, since it's hard to write and type, I'm just gonna jump to exercise 1, where all of this is already implemented.
Okay.
So the few things need to happen. We need to define performance collector, and this is going to be the main object that collects the data of our solution.
And that's the one that comes from the library then that you were mentioning?
Yes. Everything we add at this point is from the library.
Okay.
Now, when the performance collector is disposed of, it will log the files. Well, not log the files, it will log. Where it will log can be defined by the user. By default, we provide performance file logger that will actually log to a file. And here we provide 2 parameters. One is the name of the collection, and the one is name of the file. It's possible to define where that file is going to be stored and everything else. And then we create an instance of performance collector using the logger which we want to use to store our data. Now, to actually measure the specific parts of the code, since we are using iDisposable interface and using statement to wrap the code that we want to measure. So at this point, we will start the timer. At this point, we will end it and store our data into the collector.
Okay, so now you've wrapped the entire thing within the performance tracker.
Yes, entire get all employees. We've done the same for all the methods. As we can see
so
here.
every time you wrap around part of the code is probably going to be traced or part of the timing.
Yes, we will collect we will measure the time from this point to this point. So from opening brackets to closing brackets.
All right.
Now that we have implemented this, we will publish again or deploy from catalog, whichever you prefer. Now, before we start collecting data, we said we need to include the low-code app, which again we can download from the catalog. We'll click deploy, we'll select our agent, and we will deploy the low-code app. Give it a few seconds to spin. And once it's down.
Okay, so that's going to give us the low-code app, which is going to visualize the extra data that your library or that we just added with the using statements there.
Yes.
Or with the iDisposable pattern,
Yes.
And that's going to show that. Okay.
It's going to do a lot more because this low-code app this package provides a lot of GQIs that can be used. For example, if you don't need all of this, if you don't like how it looks like, how it feels, you can use those GQIs to define your own low-code app.
Yeah, make your own thing or
something that will suit your needs. Maybe you want to focus on something or something similar. Now, I have to clean up this because I forgot to do so.
Okay.
Just
you still got your previous data in there.
Yes. Okay.
It's okay. So
now we don't have any data because we still haven't collected anything. Now we're going to refresh our test app.
And that one's going to trigger the GQI code, but the new one where we added those performance analyzer methods.
Yes.
So we should see what's taking so long, or at least get an indication of where the time is.
Yes, exactly. So now we see the file that we created. Now we see the collection that we created. And down here we can see all the methods that we wrapped and how long they took, when they were started, when they ended, and everything like that. Now we can sort simply by execution time. We notice that to get all employees takes the longest, but that's because it's the entry point method and everything else is happening within it.
Okay.
But we notice that a process is taking big chunk of the time, about 90% of it.
Okay.
Now that we have identified the bottleneck, something that we don't expect to take as long, we can just double click it, and then we can see what's happening and what is taking so long. Now here we can see that these are based on code. We see that we are processing each employee individually. When we could, as an improvement, be doing this in parallel.
Okay.
And
each item I see, or each block I see there, that's because that was written in the code. It's its own statement using the performance analyzer. So you did that in a loop inside of the code probably, and then
yes,
we see it like
each
that.
block is one instance of performance tracker.
Okay, yeah. So it's not automatically every method inside of it with reflection or something. Sorry, I'm going a bit technical here, but it's like every call you have to write it yourself to say where it needs to make such a block and record the performance.
Yes.
Okay, perfect.
Using
thanks.
reflection, we do get the name of the method that's being executed.
Okay.
For example, here we are just saying performance tracker, but
it
if
knows,
we go here, we can find the exact method.
Cool.
Also you can notice that this is all nested, even though we haven't done any nesting technically, but this is nested because every performance tracker within this using will use this as a parent.
Yes.
Every immediate one. So connect one is immediate, and we can see here that connect is on the next level, but then connect has two new ones that are using performance tracker.
Okay.
And then they are nested under it.
So it matches the hierarchy of your code. Yeah.
Yes, it gives us very nice call stack, because we could be calling this method, for example, for five different places. And this way we can identify which of those 5 different places is causing issues.
Okay, very cool.
One thing as well is that the result of this is a proper JSON. Just open it here. So this JSON can be used to visualize data anywhere. It doesn't even have to be low-code app. It can be, maybe you want to use third-party tool to make sense of the data. Now that we have identified the issue, we can proceed to implement a solution for it. We'll go to our process method. And again, because it's too hard to type and talk at the same time, we're going to cheat and go to the next branch. So basically we see that few things happened here. We still have the top level performance tracker, although now we are actually storing it. Previously we were just creating it. The reason we are storing a reference to it, is because when dealing with multi-threaded environments, we have to provide the parent tracker. So the child is not able to, inner tracker is not able to figure out its own parent. And in that case, instead of passing collector, we will pass the parent tracker.
Yeah. Okay. So in situations where it's not clear, like with threading or stuff, it's easier to provide it as an argument in the call for performance tracker. All right.
Yes, because we don't have a way to track how many children there are. Now, also we can notice here that we have added some metadata. Now, it could be the case, and we'll see that this is the case in the exercise, that maybe one user is taking a long time. Maybe a specific thread is behaving slowly for whatever reason. So here we have the ability to add some metadata to better understand the context in which certain calls happened. Maybe processing took 10 seconds, but it was a large set of data, and that's acceptable. Now, this is the only difference for this approach. We'll again publish our solution. GQI will refresh the page to collect some metrics, and we can see that this is already a lot faster.
Yeah.
And we can prove that using the low-code app.
It already behaved a lot quicker. So with that particular fix, indeed, using more system resources, but we get the data quicker. So if it is a very important piece of data in your system, it might be worth doing that, indeed. And
yes.
but the important thing here is a performance analyzer, and
it's not memory usage analyzer.
We can see
here we can see that this is already taking
2.7
less than
seconds.
3 seconds, where previously it was 11.
Yeah.
And
you can
now,
also easily go back to the previous result. That's pretty quick, pretty nice to see as well. Yeah.
Yes, we can. Yeah. For example, now we have one collection because we executed the query just once, but we can open it a few times and get few collections, and then we can actually show aggregate results of those collections and to see how the system behaves over time. For example, now we have 3 executions. This one took 2.7. This one was a bit slower. This one was basically the same. Now we can open here, analyze this file, and here we can see how long all the executions took. We can check the average, minimum, maximum times, and we can do the same for all the methods to see how they behave. Let me.
Yeah, so you can get pretty detailed in there, pretty nice.
Yes. We can also see over time how the script behaves, or GQI in this case. And we can see that we started here to improve performance, although this is just a couple of milliseconds, but in real life it could be a lot more.
No, it gives you a very nice overview. It's pretty nice for when you need to debug something like that. Yeah, to measure something is to know something, is something we say in Dutch. But yep.
Yeah. And now here we can see the parallel executions. Even though they are one under another, that's simply because that's how we have to visualize them. But we can see this number 2. That means that they are all at the same depth compared to the original one. Also, we can see that if we click on any of these, we can see for which employee this was and which thread ID. We can check it. And now the exercise, and something that the end user, well, the viewer will take a screenshot of, is the last branch here or the last version on the catalog.
Okay.
Now this is basically the same, except one user is going to take significantly longer to load, well, to process.
Okay.
And now your job is to help me figure out which one.
Okay.
I'll just refresh this so we get some data.
So the performance analyzing code remains the same. In this exercise, you just change the fake data so that one of the users takes a lot longer.
Yes.
Okay.
And it's a random user every time.
Yes. So it's a random user every time. Okay, so you don't know the cheat. Okay, no. Good. Well, all right. Well, I'm going to guess we start by looking at the latest results. Taking
Those
a look
are
at
loaded by default.
Yeah. So you already have it there, I think, sorted by decrement. So we see the highest execution time, get all employees. We see the process in there is the highest one. We see, I guess we could open that one and have a look at what's inside of that. And if your code is still with the parallel, then one of those blocks, and there we go, should be relatively large. So
yes,
I think that's probably about how you do it. Am I right? Did I get it?
Yes, that's correct. It's when the Xander.
Okay.
And this will
So, and
change
then that
every
one
time
says
around.
when Xander in this case. But so it's going to be random for everyone. But indeed,
Well,
very fun.
yes, every run is going to be random. But this is something that the viewer can screenshot, showing the overgrown block with the metadata that's available.
Right. Well,
on the
very nice
site.
indeed. So for everyone watching, playing around with this, if you use that, was it the third exercise or the third branch in that code? Run that, use a performance analyzer, take a screenshot of which name it was that was the culprit of our slow code. And then, send that in as a screenshot and we'll give you your nice DevOps points. Very cool, very nice. Now, I have a question, if I can.
Yes, sure.
You said, you rerun it several times, and then in the same result file, you can see more than one of the executions pretty much. Is there a way to see the averages of all of those or something like that? Is that in there? Because
Within
usually,
the same file, or
yeah. So if you're in the same file and you have your multiple collections there, I see kata and the two kata collections. Is there a way to see the average across all of those collections?
yes.
Okay.
But this is the wrong one. We can analyze the file, and we can see the average of the
Okay.
entire execution.
Okay, so that's that. If you analyze the file or the specific call, then you'll get the averages of all the collections or all the things that ran.
This is so we could analyze this file specifically for this method, or we can analyze multiple files that contain the same data for the same execution.
Okay.
And we can analyze the file as a whole like this. And then here we can see all the executions, how many times they happened, how long they took. And then for each of them, we can see minimum, maximum, and average values.
Okay, cool. Very awesome. A lot of information and a small visual package that's easy to navigate through. Yeah, I like it. I like it a lot. Okay, was there anything else you wanted to show us on the performance analyzer? So we've got the library, a little bit of coding there, but most importantly, it's the data you get from it, the low-code app we provide that you can already work with. Very fun to see. I don't know if you had anything else for us.
No, this is mainly it. There's a lot of details and intricacies, but those can be found in the documentations. But this is just getting started and being able to.
I love it. It's indeed. I think it's a very, very useful thing for a lot of people, a lot of developers, a lot of DevOps to include all of that. Yeah, cool. Yeah, I'm impressed. That's all I can say. So, for everyone who was watching, remember send in that screenshot of which name was the culprit for you, and we'll give you your nice DevOps points. Other than that, Edip, thank you very much for making time to prepare all of this for us.
Thank you for having me.
I know it's very fun to do a remote one like this. It's very different, but I love giving the opportunity to everyone in the company to show these interesting things, and this was definitely one of those. So everyone watching from YouTube, don't forget, like, subscribe, ring that little notification bell so you're always aware of new videos like these. And other than that, I wish you all the best, and I'll catch you in the next one. Goodbye.